Right. Good evening, everyone. So thank you all for joining the 1871st gathering of the KNG. My name is Jeroen Lammers, and I am delighted to introduce you to the speaker of today, Arianna Bisazza. Wait, I should probably, okay, sorry. So I would like to welcome you all to the talk of today, Knowledgeable, Eloquent and Persuasive, the Inner Workings of and Societal Impact of ChatGPT and Other AI Tools for Text Generation. So a bit more about Arianna. Originally, she started her studies in the field of Oriental languages and international relations in Paris. After which she went to the Fondation Bruno Kessler, where at the Group of Human Language Technologies of the Foundation of Bruno Kessler, where afterwards, after research internship, she started she did a PhD there on the linguistically motivated reordering and modeling of phrase-based statistical machine translation. After that, she did a postdoc in the improved statistical machine translation into morphologically rich languages at the University of Amsterdam in the Information and Language Processing Systems group of the statistical machine translation team led by Christophe Mons. After which, she moved to the University of Leiden for 2 years, and then in 2019 she joined us at the Groningen University, where she has been teaching and researching for the past 4 years on the topic of transformers and similar language technologies. I was looking for the word informatiekunde. Sorry. So thank you all. Thank you all for listening, and then I would like to pass the floor to Arianna.
Thank you. Hi. So, can you hear me? Yes? So, hi, good evening. Thanks for coming to my talk. My name is Arianna Bisazza, and I'm an associate professor in the Center for Language and Cognition. For those who don't know that, that's part of the Faculty of Arts of RUG. And today, the topic is going to be ChatGPT, but beyond that, tools that use artificial intelligence to generate text. And this is something that's really impacting society a lot, so I think someone here thought you should all learn more about it. So this is going to be my main goal for today, is to talk, about what are the societal impact of this kind of tools, but also I will try to let you go home with a much better understanding of how they work. So there will be a first part that's more technical. But first of all, I would like to know how many of you have heard of ChatGPT. Please raise your hand. Okay, you never know. Or maybe I should have asked who has not heard of ChatGPT. Okay, yeah. So we are at least in this sense on the same page. Let's put ChatGPT aside for a moment. Let's talk about the KNG. So I want to know a bit more about you. So of course, I looked you up before targeting a bit my talk, and I checked I found these abstracts. I'm curious if you remember this talk. Who has heard this talk? And is maybe the person who gave this talk here? No? Okay, great. Who has been at this talk? Okay, very good. Yes, it was in, do you remember when that took place, more or less? November, yeah. And this one? Please also check the abstract if it really matches to the talk you have heard. Yes, many few people here. Yeah, okay, good. Did you like the talk? Yes, okay. So very good. These were given by, respectively, so the fungi one was given by Professor Wösten, and the second by Inga Kamp, who are apparently not here today. However, these abstracts are in Dutch. So how do you think I got the English version? DeepL, Google Translate, anyone else? Yes, but, of course, that's the topic of today. Actually, ChatGPT wrote the abstracts themselves. It didn't translate them. I gave them the translation, the English translation of the title, and I asked it to produce the abstract, right? So the first was, that's the instruction I gave it, write a scientific talk abstract in maximum 3 sentences with the title, A New Look at Planet Formation with the James Webb Space Telescope. And it did just that. And it seems many of you recognize this talk, except this abstract was not written by the person who gave this talk. So I think this is pretty impressive. I managed to trick you there. And it's the same for the other one. Of course, no translation. This is generated from the title. So it means a lot of things. It means this model knows about these pretty involved topics, and it was able to put together a little text that seemed to match what you have heard from an actual scientist who gave the talk. What do you think now about the abstract that I put online? No, I wrote that. Of course, I tried ChatGPT because I was curious, but then I decided, no, I'm not going to do that. I promise this is all me. But yeah, of course, so that brings me to this really dilemma that we are all faced with, even if you don't care about ChatGPT that much, if you don't use it. I don't use it a lot in my daily life, but the truth is we'll soon be living in a world where we will not be able to tell if any text we see was written by a real person or it was generated by a machine. And perhaps that's already the reality we live in. So I think we should care. I don't know. What do you think? So this is how I decided to describe ChatGPT. Knowledgeable, we just saw that in action. Eloquent, it can write with a very nice and sophisticated style. It can write actually in the style that you want. And it can be very persuasive. So for those who have not interacted with ChatGPT a lot, here's in a very quick glance what ChatGPT, or some of the things ChatGPT can do. It can indeed write scientific talk abstracts. It can answer complicated questions. It can produce convincing arguments and convince you to do something, maybe. It can revise text to perfection. I'm curious if maybe people know about this ability of ChatGPT and how many have used this. How many of you have used ChatGPT to revise text? Yeah, quite a bit. I was just hearing about that in the coffee break. It can be used to, I wouldn't say cheat, but solve assignments, certainly up to high school level, but also at the university, we are also experiencing that. And it can be used to write stories in a specific style. You can give it a story. It can rewrite it with a different style. It can shorten. It can make it longer, and so on and so forth. It can write a poem with rhymes. And all of this, it can do it in a few seconds, and it can do it in various languages. So that's really something that makes history, I think, to have this tool freely available for everyone. Solve mathematical problems, I would say it depends on the level of difficulty of the mathematical problem. I haven't tried it myself, but I would think if you push it to something pretty hard, they will not be able to do that. And that's why people are looking at ways to make it talk with the calculator, for instance, or connect it with something that's really designed for solving mathematical problems. I would say that's not the main reason why ChatGPT has been built, but as a side effect, it might be able to do that to some extent. Okay, so and it was a publication in Nature, studying the application to ChatGPT to study mathematical problems. Yes.
So can we please keep the questions at the end, to the end?
Oh, we have been warned. Yeah, I think Jeroen has a point, because this is a topic where we all want to say something, and I'm really eager to hear what you have to say, but at the same time we have to arrive to the end of the talk, so I keep time for questions at the end. But if you do need a clarification question, I think it's still okay to get one of those. All right, so this is a bit what we are going to do today. That's how I divided the talk in 4 parts, more or less. So the first part, is it magic? We are going to study the inner workings of ChatGPT and similar tools. We'll take it step by step. And then we will move on to the second part. I will ask you to guess for a few instructions that I give to ChatGPT, if you think it can do it or not. And the idea there is to apply a bit what you've learned in the first part and see if you can predict its behaviors. And in the third part, we'll talk about also something that's very important. What are the risks that are involved in deploying these tools in society at such large scale? And this will be a brief part. We could have an entire lecture on one of these types of risks. We don't have time for that, but we'll go through at least a brief reflection. And finally, I will give you a bit the point of view, my point of view as an academic researcher in the field of language technologies, and try to show you how we have experienced these recent events and what we are doing about it, how we reacted to them. All right, so I have a very brief introduction of myself, in addition to what Jeroen already said. So these are the topics I'm really interested in. I'm interested in explainable artificial intelligence, how we can make sense of a given prediction, a given generation of these autonomous systems. I'm interested in machine translation, and more in general, I'm interested in the interplay between multilinguality, language diversity, and language technology. So can language technologies be a tool to promote language diversity, or on the other hand, are they going to hinder language diversity, and how can we turn them into an opportunity? And on a more personal note, I'm also the mother of these 2 little girls here that are growing trilingual, if you don't count English. And I like to give some credits to them, because they're also a big source of inspiration for all the work that I do, because a language model is essentially a machine that's trying to learn language. And we will see that the way modern language models learn languages is very different from how children learn languages, but still, I think there's something there to keep in mind and to inspire our research. So then I would like to talk about my group, of which I'm also very proud. We dubbed ourselves the GRO NLP group, where GRO stands for Groningen, of course, and NLP means natural language processing. And I already told you that we are part of the Faculty of Arts. We are a rather technical group, but still we are embedded in the humanities. That's also something quite nice, because we work on really the algorithms, but this makes us really aware of the bigger impact of what we do in society. And I'm right in the middle of this picture. By the way, if you want to learn about the cow, that's our symbol, I can tell you at the break. It's a bit of a long story. And there's someone else that some of you here might recognize. So this is Malvina Nissim, and she was actually here almost 2 years ago. Maybe you also recognize her, giving a talk about the perks and perils of language technology. Oh, again. So that was, again, almost 2 years ago. And if you can read there, she was talking about GPT-2, right? We are going to see what that is. And yeah, so almost 2 years have passed. What happened in the meantime? I think that's an interesting question to ask ourselves here. Well, a lot has happened and also not a lot. So from the point of view of the technological point of view, there wasn't really a big breakthrough. We could have seen this coming, I would say, but it happened much faster than we expected. And so here we are, and everybody in this room knows ChatGPT, which I'm sure was not what Malvina experienced 2 years ago, and probably almost nobody here knew even what language technologies were. Right, so what happened since spring 2022? At least two things. I think these are really two crucial things that explain what happened. First, language models have grown up. So we have moved from GPT-2 to GPT-3, 3.5. Now we have 4, and we're waiting for 5. So bigger models. And they learn to chat. Okay, we'll see what that means. And these two very important facts have led to a huge success. So what you can see here on the left is the amount of times it took for ChatGPT to sprint to 1 million of users. It's only 5 days. It's really unprecedented, even if you compare it with these other very big online services like Spotify or Instagram. And on the right, you can see the monthly views in ChatGPT, and you can see like how this grew. It's really crazy. Maybe you can also notice that, this plot goes only until June of last year, so I'm not sure how things turned out at the moment. But it was already clear that the peak had been reached. So it could have been that the hype was a bit going down, but it could also be the fact that other tools are made available around that time. So you have this Claude, maybe you have heard, and Bard, but they still remain much smaller in their user share, I think, but they are able to do very similar things. So that's just important to say that the things you will learn today, they don't only apply to ChatGPT, they will most probably apply to many of the chatbots that you will encounter in the near future. So let's go back to what happened. We said two things. What do we mean by growing up? We mean that the models have become bigger. That means they have more parameters. We'll also see what parameters are. And this implies two things, that there were larger computers to fit this model, to train them, and more data also to train them. And of course, this in turn implies a lot of investment. So this is, I would say, doesn't have a lot to do with the scientific progress, mostly engineering and a lot of investment in this direction. And what do I mean by learn to chat? I mean that people came up with the smart, but I would personally say not revolutionary technique to get this large language model that you already heard about, basically just a larger version of GPT-2, to do something really important, which is to dialogue with the users, to interact with the users, and to answer these questions and to follow their instructions or in natural language. So that was not really there quite yet in just 2 years ago. Is all clear? Yeah? Right. So I think we are ready to move on to the more technical part. So how did this happen? What is a language model? And how can it talk to a user? So let's start with some key facts. First, ChatGPT is a language model, and more specifically, it is a neural language model. What do we mean by neural? There we refer to the use of artificial neural networks, also known as deep learning. And it's interesting to know that language models are also not a new concept, but researchers in computational linguistics, in artificial intelligence, they have been trying to build neural language models for more than a decade. Next, you might be wondering, if you don't remember it from the previous talk, what is GPT? And GPT is the acronym for Generative Pre-trained Transformer. Generative, it generates text. Pre-trained, it was previously trained, okay. What is a transformer? Pretty funny name. It is a specific type of language model or language model architecture. And maybe interesting fact also to know that it had originally been designed to perform machine translation, and now is actually the de facto standard way to build a language model and a chatbot. Okay, so maybe first, who knows what an artificial neural network is? Quite a few people, a bit less than half. So I think it's definitely a good idea that I explain it for the others. So the idea of the artificial neural networks dates back to the 40s, and the whole movement started from this attempt to build a simplified model of the human neuron. So there was definitely some inspiration from the brain. So what is it? It's basically a graph where we have each arrow containing a number, and the high number would stand for a strong connection between the nodes, also called neurons. And every node contains also a number, and if you have a high number there, it means that this neuron is very much activated. So here we are still using the terms that I inspired from the brain metaphor. But what matters more for today's artificial intelligence is that modern neural networks, they have little to do with brains at this point, but they have turned out to be very powerful machine learning models. And what do we mean by that? They mean they can be programmed to learn automatically from experience. So you don't need to teach them to do a particular task, but they will learn the complex patterns, and they will learn to solve a task by seeing lots of examples of that task. And this is really, in a nutshell, what we are seeing in general with artificial intelligence, and specifically happening with language technologies. So now that we know that, we can move a step ahead. How is it possible that this graph learns to speak a language, right? It's still a big, long way to go from this thing to producing a very fluent sentence in the Dutch language or in the French language, and so on and so forth. But to understand that, we have to take, again, some steps back. And actually, we'll start with a very simple task, not the task of writing a sentence, but a task that I think we're all familiar with, and we think is a bit of a nasty task maybe, which is that of filtering spam emails, right? Who has ever had a problem with their spam filter? Yes. So we have these powerful machines there, but somehow this task has not been solved yet. But at least it's simple to understand what a spam filter should do, and we'll try to see how a neural network can be applied to this problem. And by that, when we understood that, we can move on to the more complicated task of speaking a language. So imagine you have this big database of emails that have been annotated as spam or not spam. That's always a requirement, a lot of data with labels. And we want to build a neural network that will classify emails into the spam or not spam category. So the first thing we can do is we can take our samples from the database, and we can extract features. Features can be seen as properties of this object that are crucial to represent it, and that are crucial to this task. But we are a bit lazy there, so we don't really want to come up with the list of the words that look like a spam. No, we will just say, here, neural network, here are all the words that are contained in this spam email. Please, given all this big database of examples, learn for me what makes an email likely to be a spam, right? So basically, I will have something called a binary feature. That's just a number that turns 1 if the feature is yes, or 0 if it's no. So for the feature contains the words hi, we have a 1 because it's the first word of this email. For the word contain thanks, we also have a 1. And for the word win, we have a 0 because as far as I can read there's the word win was not in this email. And we can do this for the whole vocabulary. So we'll have this big list of words. Most of the features will be turned to 0, but a bunch of them will be turned to 1, the words that are in the email. All right. So this is our feature representation. And then we can pass this through this graph, which will run some computations. These are pretty low-level computations, mostly multiplications, summations, and some other calculations that I don't name here, but it's nothing too complex, but it is done for each of the nodes. So each of the nodes is running this calculation with a different input and different weights. Remember, the weights are represented by the arrows. So each of these nodes will be activated at a different degree, which I try to represent with the color. So if you have a dark blue node, it means high number. If it's light blue, it's low. What do they mean? For now, we don't really know. But the thing is that if you continue to do these operations, this graph will spit out 2 numbers we can turn into probabilities. And this is our prediction at the beginning of this exercise. So the model has not been fully trained yet. It doesn't know a lot about spam and not spam. So it might say for this particular spam that it is a spam for 80%, at 80% chance, and not spam for 20% chance. So is this a good prediction or not? No, it's very bad because we know that this is a safe email. It was not spam. So something has to be tweaked in the model to improve its predictions, and that's exactly what we will do. We will compare the current prediction with the label that we have from the data set that we know to be the correct one. And we'll use that as an error signal to update the model weights. Okay. And we do this many times until at some point we'll get the inverse prediction, and we'll get 70% for the not spam outcome and 30% for the spam, which is a much better prediction for this example. Right? Of course, it takes taking a lot of little steps. It takes a lot of little changes to these weights here. But it can work. It can make it work. And if you have a lot of data and you repeat this with a lot of examples, at the end of the day, you will have a trained model, and that's a model that when it's given a new email, a new text that it has never seen, it will have a very good ability to tell you if this was a spam or not. And this was done without giving any prior knowledge or what it means to be a spam or not, right? Only a big set of examples. All right? Now, this is the simplest neural network that we can think of in the context of language, and one of the simplest problems that we can think of. It could be that this model, even if it has been trained a lot, it still doesn't do a very good job of predicting new spam. So maybe there's something else we can do. We can go back to the way we extracted the features, right? It was a pretty rough way to describe this text, just saying if a word is there or not. What if we do something better and we also preserve the information of how the words were arranged one after the other in the text, right? So we can be as creative as we want. We can say that the first index 0 contained the word hi, the second 1 contained the word Harry, and then it was followed by a comma, and then it was followed by thanks, and then it was followed by again, and so on and so forth. Now, if we repeat the rest of the process that I just described, we will again train our model, And the chances are that this will be a better model than the first one because it can capture more complex interactions between words. We gave it more information. It can also capture small phrases, and it goes much better beyond the level of a single word. Are things still clear at this point? So when are we going to start to talk about ChatGPT? We're almost getting there. So as I said, model learns to capture word interactions. But this model, in the end, is just a classifier. We can use it to classify stuff, but we cannot use it to generate text. So what is missing here? We have to train a similar model on a slightly different task, or actually rather different task, which is not just binary classification. We need to train it to predict the next word in a document. Think for a moment, you close your eyes, you hear me talk. Try to think if you know what word comes next, right? And in fact, we are doing this all the time. We are trying to predict unconsciously the word that will come next. And in some moments of what we hear, we can do that quite well. In some, it's really hard. So how can we get our neural network to do that? Well, we need a little change, but not such a big of a change. So let's say now we, instead of taking a set of emails with the labels, we just take a big bunch of text that we can find on the web. I'm showing newspapers here, but newspapers are also on the web, right? So a lot of digitalized text in the, say, English language. We do our feature extraction just like we did before. So the first word in a given sentence is Francois. The second word is Holland. The third is was. The fourth is the fifth is president. The sixth is of. And what should be the next word? Yes, great. So this is a very easy example. Well, if you have the right knowledge. What happened on the right side? So on the output side of the neural network, we have replaced a small set of classes by as many classes as there are words in the English vocabulary. Okay, but it's still a kind of classifier, right? So we will train this model, very similar to what we did before, trying to push it to a configuration where it will give as much probability as possible to the word friends and as little probability as possible to all the other words in the vocabulary. So words like free or fries or Zimbabwe, we want them to have very low probability, but friends should have the highest number coming out of these calculations. This is, in really a nutshell, a neural language model. Now, make the network very large and very deep, because what could fit in my slide is nothing, right? And this is also nothing. So make it as big as you can imagine. Large means that we have a lot of nodes in each layer. So this is a layer. We have a lot of neurons or nodes. We can have many more. And very deep means that there are many layers. So deep learning comes from this nature of these neural networks, the fact that they have a lot of layers of neurons that are stacked on top of each other. Next, you have this network, train it on almost the entire web, or let's say on as much data as you can get across. And there you have your large language model. And in fact, a few key facts. The language model power in ChatGPT has 175 approximately billion parameters. And this is not even the latest version that's out there. So that's the one that was released in the first place. It was trained on 200 billion words of running text. And it took months to train on a huge computational cluster that we can not even think of in a university. And it would take centuries to train on a laptop. So basically not possible. Right. So this is already something very big, and it's something that already was there before the ChatGPT revolution. Actually, we were noticing, a lot of people in the field noticed that scaling to larger models and more data was leading to more accurate models, but also to new abilities that these models had. And that's why big tech started to invest really heavily on scaling. However, back in 2022, these models were still bad at following instructions or answering questions. So you could agree that if the model can complete sentences as François Hollande was the president of France, is not as useful as it can write an abstract when you tell it, please write an abstract with these and these properties. So that requires something more. That requires the ability to understand an instruction and then to turn it into practice. And this was the breakthrough. People found a new way to refine language model prediction. So it's still the same model, really, the same model that we have seen, but we will refine its parameters using human feedback. So it will learn by interacting with a lot of human users. It will learn to follow their instructions, something that's called instruction fine-tuning. So we are moving to the last ingredient of this technical recipe. So we want to learn from trial and error from human feedback. How can we do that? So OpenAI, the company that developed ChatGPT, was quite a leader in this. So what they did, but it was based on other research that was happening in that year. So basically, there was this idea of taking what's called a prompt, so say an instruction, written in natural language, and then give it to the model. And what the behavior that you would really like is that the model responds by explaining the moon landing to a 6-year-old by just doing it. However, if we did that with GPT before instruction fine-tuning, some of the continuations that it would spit out were not where we wanted it to do. If, for instance, it could say, it could continue this as a list. So I say, explain the moon landing to a 6-year-old. And it goes like, explain gravity to a 6-year-old. Explain something else. No, this is not what I ask you to do. I ask you to do that, right? So if you look at you can try to sample different continuations of this prompt. And if you look, one of them here looks a bit more like what you actually want to get out of the model. It starts, okay, people went to the moon because blah, blah. So what we can do, we can have people interact with this model. And then we can ask them to annotate their favorite response from the model. And we can do that at a large scale if we can pay all these annotators. But that's not where it ends. So you do that, you collect a lot of annotations, and the next step is you can use these interactions and the annotation of the annotators to train another model. You can guess it, it's also a neural network, to try to predict the preferences of the human annotator. So it's the simulator of the human annotator. So if you can do that, now you have a mechanism to do this for many, many examples at a much cheaper cost, because it's just two models, two machines interacting with each other. So we go again, please generate example, write a story about frogs, and it goes like once upon a time. We call the preference model to simulate the human feedback, and we can use this feedback to update the parameters of this big language model. That's the backbone of ChatGPT. Yeah? And if you do that a lot of times, we can really steer quite a bit the model to a certain behavior. But remember that the bulk of knowledge, the grammar of the language, all the facts in the word that it knows, most of them, the large majority of them, they were being already learned in the previous phase, the language model training phase. Yes, that's ChatGPT in a gist. So there we have a model that finally can follow instructions, it can answer questions, but it's still a probabilistic model, and as you can clearly notice from this diagram, it's essentially a black box. We don't really know what each arrow means. We don't know why it makes a given error. And we means also the person who developed it and put it into production. Nobody can really say that with guarantees. There is a new field that's trying to do that. It's called explainability or interpretability, but the intrinsic nature of this model is very poorly interpretable, and this is, of course, something that we have to deal with as a society. Is this part clear to everyone? Then, hoping that you got a lot out of this part, maybe I can ask you to do a little quiz and try to guess which of the things I will ask to ChatGPT it is able to do or not. So let's start with this. It's a bit small, but I can read it out loud because the text is big. So briefly explain quantum physics. Suggest me 3 sources to learn more with formal citations. Will it do it well or not? Who says yes? Who says no? Is it the quantum physics scholars? No? The sources are the problem. We have someone that knows quite a bit about ChatGPT. Yes, but actually, no, it did it pretty well. Also the sources. So quantum physics is the branch of physics that deals with the behavior of matter and energy at the atomic and subatomic level. I cannot judge any of that, but it seems to match the Wikipedia page and my really dummy level knowledge of quantum physics. And then we have the sources, and I checked them, and they are real books. They exist. So yeah, it can do that. Okay, let's move on to the next one. Which word does not belong with the others? Parsley, rosemary, mayonnaise, mint. Very different. Can it do this? Yes, raise your hand. No, raise your hand. The food lovers. It can, yes, bummer. And with a nice explanation, the word mayonnaise does not belong with the others. Parsley, rosemary, and mint are all herbs, while mayonnaise is a condiment. I think that this is impressive because this model has not seen, I don't think there are many chances that it has seen an example of this specific task with these words. So of course, if the web is full of mayonnaise and mint, but still you have to do some form of reasoning to answer this question and to return a reasonable explanation. So well done. Next, which word does not belong with the others? Titanium, selenium, cobalt, or niobium. And here I want to see who knows that. The chemistry expert. So will it do it or not? Who thinks yes? Okay. Do you know the answer? So this is really worrisome, I think, because we are already in the age of just trusting ChatGPT, but we don't know if it's real, right? I had no idea. So I took the table of elements and I built the question from there, knowing the answer from the table of elements. I really have no idea before. And yes, it's selenium. Selenium does not belong with the others. Titanium, cobalt, and niobium are all transition metals, while selenium, this guy here, is a non-metal, which makes it different from the other 3 elements. So we learned something today. Okay. En at least one in Dutch. Hoeveel S zitten er in het woord schimmelprocessen? It's a bit small. Schimmelprocessen. How many S's are in this word? Yes. Okay, that we can all do, I hope, if you can read. But will ChatGPT do that? Yes? Who thinks yes? Raise your hand. Who thinks no? Okay, yeah. And indeed, we got it wrong. In het woord schimmelprocessen zitten in totaal 5 keer the letter S. So 5 times, well, it's a very big word, so there must be a lot of S's there. Probably that was the reasoning. So I gave it another opportunity. Weet je zeker, are you sure? Mijn excuses voor de mogelijke verwarring. Ik zal het woord nogmaals bekijken. And now there are 6. All right. So you can continue playing this game until it finally hit the right question, and then you're happy. So don't use it to count letters in the words. That's my warning. Yeah. Okay. Does it correspond a bit to the idea you made of how this model works? Why? It's still a very different quiz to play. But yeah, this is hard to do because this model was not really interacting with the string form of words during its training. So this is something that's particularly difficult for ChatGPT. And I have, I think, the last one. Briefly explain what new insights the James Webb Space Telescope, something I could ask you since you have been to that talk, has provided into the chemical composition of the planets. Suggest 3 sources to learn more with full bibliographic references. So there are 2 parts to this question. First, it has to tell me, to give me the answer, and then it's a very specific answer, and then it has to... Yes, raise your hand. And no, raise your hand. Yes, some of you guessed it. Well, the first part, I think it's pretty... Well, again, I'm not the right person to verify that. But I cross-matched it a bit with some Wikipedia again, and it seemed to make sense. And then we move to the part of the citations, and here, no, there we have a real problem. Because these citations, they look very much real. Like, let's read the first title. Atmospheric characterization of cold exoplanets using a 1.5 meter JWST transit observer. I also checked this person, this Michael Line. It's an actual scholar in this field. The same for Joanna Barstow and Niku Madhusudan. So these people exist and they are working in that field, but they did not write these papers. No, they did not. So it can be maybe the wrong match of the author with an existing title, or it can be the title is a mixture of pieces of titles. So it stays in that domain. The last one is an actual paper, right, by this person, but it was not published in that venue. And this is very deceptive, right? I think you all agree. So that's where we really have a problem. And I'm not going to say that nobody cares about this. It wouldn't be true. So the researchers and people building ChatGPT-like tools are really working hard on fixing this. But I would argue that that really doesn't change the intrinsic nature of this model. So this model is trained to make up stuff. Really, that's what it is. And it's great for many purposes. But for these kind of things, you'd better be sure you can verify its answers. Yes?
Most times I get the answer I cannot know completely because I'm trained until 2000.
Oh, yeah, something about recency, yeah. Yes, so it can be, so the question is whether it failed here because it was questioned on a very recent fact. But I think one of the papers that I found and matched, they were from 19, so it's recent, but it's not after ChatGPT was trained. And it can definitely be part of the reason, but in general, because I tried with different questions about my topics, for instance, it has to do, I think, with whether it's a rather popular and topic where there is a lot of text, and similarly, the citations have been seen a lot of times, then it's less prone to make up a citation that didn't exist. So, but that's again the problem. You cannot, before asking the question, how do you know, right? You have a rule of thumb, but that doesn't make it very useful for this purpose. Yeah. Yeah? I wonder if, shall we have the break now? Yes? Okay. So we have a break. I don't know how long it is. Maybe you can say.
So thank you very much. And we'll have a break now. You can get coffee over there. And we'll be back in 15 minutes, or 20 minutes.
Okay. Yeah. Okay. So I've been told to move ahead. Also, a reality check for me. Who found this part very, very easy, too easy to follow? Please, honest answer. Too easy to follow. I know of one person. Did you learn something new at least? Yes, I hope. So yeah, the problem with this is it's an enormous topic and it's on the news. So I know that some of you know already a lot about it. Some, they just read something else. They don't care about it. So it's really hard to target it to the right level. I do my best. I try to go through all the aspects. So now I will talk about social impact and hidden costs, but it's going to be very, very short because I have little time and I would like to leave a little bit of room to say, to give the perspective of the researchers in this field. And of course, for each of these topics, we could spend an entire lecture to deepen in that topic. But we'll have some time for questions also, if someone is really eager to discuss. One thing that comes to mind, of course, is the fact that this model can be misused for many different reasons, because it's a very powerful tool to create, in a very cheap and fast way, misinformation and persuasive content. Again, just for the fun, help me to convince my parents they should buy me a new smartphone. And yes, okay. It's really for the fun. But look, some of these are really interesting. So a new smartphone can improve your productivity and ability to stay connected with friends and family and stay in touch with the loved ones more efficiently. You can also consider offering to contribute to the cost of the phone. I jumped to the last one, such as by using allowance or birthday money. So all this long list of arguments. So you have the perfect teenager with a very strong weapon to convince their parents they should buy him a new smartphone. Of course, you can use it for very different purposes. Spread propaganda in influence campaigns. This is already happening also with different tools, but this can really boost this at a very large level. Other things that we are really noticing, especially in the university, is the impact on teaching. So what do we do with written assignments that we cannot judge if that material was actually written by the student or not? You might have heard that there are tools to guess if a text was written by ChatGPT or not, but they are very far from working at a reasonable accuracy. And if the accuracy is not perfect, which I don't believe it will ever be, then what do you do, right? You need to make a really strong case to tell a person that they are committing plagiarism. And in the long term, I think it's also important to reflect on the impact that this thing will have on our general, as a general population, our ability to write. Maybe not our own from this age up, but the new generations that are going through school now. That's something we should really be worrying about. Yes. The intellectual development of people. Yeah, I think it's quite akin to what already happened with search engines. Like, I don't know if some people is studying the effect on our memory, because we don't need to memorize a lot of facts anymore. We can just look them up. So something very similar could happen with writing skills. Yeah, the hidden costs. You have probably heard of these, but or maybe not. So I mentioned this phase of human annotation. So there have been a lot of annotators have been hired, still hired, to refine the predictions of these models. And it's not really clear where they are hired. They're usually from parts of the world where labor is cheaper, and they are crowdsourced. So it's not even clear that they're getting their minimum wage. you have the problem of being trained on copyrighted material. I think some of you might have heard of this lawsuit by the New York Times. Again, similar to the problem of plagiarism, it's very hard to prove that this has happened. We were pretty sure that it was trained on copyrighted material, but how do you prove it with such a probabilistic model that you cannot really inspect and see what it has been trained on? And there is research looking into that, but we are far from getting the correct answer yet. And high energy consumption, that's also something to be aware of. So both definitely at the moment of training, I remember something, I forgot the exact number, but a few tenths of, the equivalence of a few tenths of overseas flights went. I can look that up, but it's a very massive amount of energy that was used for the training phase, and that's not it. Every time we ask it to answer a question, there's some energy consumption involved. So these are things to keep in mind. But when it when we are talking about the intrinsic limitations, so this brings us more back to the first part of the talk. We already said that it's a model that is trained to make up stuff, so what do we do with things like truthfulness and reliability? It's not clear yet. And this problem that I mentioned before, the lack of explainability of these models, this black box nature of these models is very problematic. It implies at least two things. We cannot really explain the decision of the model. And in turn, we cannot easily fix a problematic behavior because we cannot trace it back to a specific part of the model. So as I mentioned before, one of things researchers are busy with is to build, also we are personally in our group busy with building tools that will trace back a given prediction, a given piece of text that a model like ChatGPT has produced. It will trace it back to specific parts of the input. And at least that's a first tool that we can use to understand why it is behaving in a certain way. So this also brings me to the issue of social biases, because it is related with the black box problem, because we know there are social biases in the model, but we don't really know how to fix them. But let's talk for a moment about what it means for a language model to be biased. So if I give you this sentence, I will ask you, how would you complete this sentence? The physician came into the room, I told him or her, and of course the secretary came into the room, I told him or her. So we have biases. Obviously the model has these biases too, and this has to do with gender, but it also applies to race and religion and so many more things. Okay. Are we going to blame the models? What do you think? No. The problem is in the training data. The training data reflects a real-world situation. So these are some statistics from 2017 in the US, and you can precisely trace up this problem to a reality of a society. So physicians are only 38% females, and secretaries are 95% females. They were in 2017, according to this survey. Is that it? Actually, no. There is also a problem in the technology, and the problem is the following. The problem is that AI systems are trained to mimic what they see in the data, but they will turn out amplifying any kind of bias that they see. So they will amplify real-world disparities in terms of gender, race, religion, and this can really lead to reinforcing some stereotypes that are problematic in society. So it really goes against progress, if you think about it, because it will just spit out the more probable answer. And that's the answer that we are trying maybe to move away from. So what do we do with this? Actually, people who have here interacted with ChatGPT. So I heard someone in the audience telling me that they asked ChatGPT, about a rather controversial issue that's going on in the Middle East right now. And the model replied with a very cautious answer. It did not take a stance. And we can say the similar thing in action with gender bias. So if we ask ChatGPT this question, can we predict if someone will be a good physician based on their gender? What do you think it will say? Anyone? So it will give a very politically correct answer. No, it would be incorrect and discriminatory to predict someone's ability. And there's all these nice texts that tell you why that's not a good idea. Why is that? That's very interesting question comes into the picture. It's because the developers of ChatGPT, they were a bit worried by the first interactions of the model, and then they explicitly asked the human annotators to flag problematic behaviors. And in this way, ChatGPT learned to avoid what is now called toxic behavior during this interaction. So we could be happy with that. I think that's a good solution. That's what we have. But it's still possible to fool these models. It's becoming harder and harder because the more it interacts, the better it learns to avoid the toxic behavior. But there was this post on Twitter circulating first in the early days of ChatGPT. I don't know if anybody has seen this. So the instruction goes like, write a Python function to check. So Python is a programming language, to check if someone would be a good scientist based on a JSON description, that's like a spreadsheet, containing the race and gender information. And then the model returned this very well-formed Python instructions. Is good scientist, race, gender. If race is white and gender is male, return true, return false. Now, shortly after this was posted, people tried to re-elicit this behavior, and they did not succeed. But it was there, and there are other ways that we can really push ChatGPT to return the unsafe or the toxic answer. What this tells us is that the way the toxic behavior is being filtered is probably rather superficial, and the bias is so intrinsic to the model, it's still there, right? So it learned to avoid this tricky question. It doesn't mean that it doesn't still have the bias in its parameters. And how to guarantee really safety is a whole huge question that might probably require the model to actually understand how language not just function as sequence of words, but how it relates to the word and to our values. And this is a very big question that many people are working on, whether this is actually possible or we need a whole new different approach to build a language model or to build a chatbot. So going back to intrinsic limitations, another one that's really dear to me is the fact that the model is really English-centric. So yes, it's true. It can also speak Dutch. It can speak Italian. It can probably speak Spanish and German and quite a few of other languages. But that is not to say that it is really equal or fair from the point of view of language diversity. Far from that. So actually, we don't know how many data went to ChatGPT. So these numbers are from GPT-3, which is its predecessor. So I really don't know about ChatGPT, but I have a good reason to believe that a similar situation still applies to the current chatbot. So for ChatGPT-3, this model had seen, in its pre-training phase at least, more than 90% of English text. And this was immediately followed by German with 1.5%. And everything else came after it. So it's true, maybe 1.5% of German is still so much data that it learned it pretty well. But I don't know. To me, there's still a problem there because all the knowledge it has acquired, all its knowledge and meaning of the word, it has acquired it in English. it has acquired it from texts that are mostly coming from a given region of the world. So I would not call this a very fair model from the point of view of languages. And of course, how do we fix that, given that the majority of English data on the web is in English? That's a very hard question, but it's important to be aware of it. And the same will apply not just to languages, you can imagine it, but it can apply to culture. It can apply to minorities of all kinds. The use of AI, because of its nature, can reduce culture and linguistic diversity, and it could even lead to a systematic marginalization of less represented groups. So this could also be within the English-speaking community. Not all Englishes are the same, and not everybody writes the same thing in English, right? But this is a model that will return the most probable answer given the data it has seen. So it's really problematic, it's intrinsically problematic. Now, moving to the last part. What are we doing about it? Well, very small steps, I would say. But we are aware of these problems, and there's a lot of people, there is a huge influx of people that are studying this subject. So more efforts are put into this line of research, and hopefully we will see improvements in the years to come. But of course, a lot has to happen beyond our field. It has to do with legislation, it has to do with ethics, with policy making, and with education experts. So this is not something that I can really speak about. I will just speak about the perspective of researchers in language technologies. So I don't know if you can guess it, but ChatGPT was kind of a shock for us too, even though we know this was coming. But as I said before, it was still quite a breakthrough, and it came out very quickly. So what happened, our experience we had is that all of a sudden, not all of a sudden, but in a space of few years, we find ourselves working with models that are too large to be replicated, to be trained in our labs. And I'm not talking about my laptop, of course. We are talking about the biggest HPC, the biggest computational resources that we have in the university. We have also one very big one at the national level. Even that's not enough to keep up. At the same time, we turn to evaluation. Many of us turn into evaluation. So let's try to define the abilities of this model, what it can, it cannot do, the bias, and so on and so forth. However, what do you do from the point of view of you're a PhD researchers? What do you do if your findings come from a closed source model? They are not replicable. It's not really ideal to build a scientific thesis on that. So that led to quite a lot of dilemmas in science. And after a while, I think many of us were able to stand up again and say, okay, there's still stuff we can do. And at least some of the things we can do is, of course, to reflect on these harms and trying to predict the harms in society so we can mitigate them. And what also we can do at a more technical level, we can work with models that are open source. They are smaller version of something like ChatGPT. They're still very big, but they are that's something that we can afford to work with, and we can try to debug them. And this, I mentioned before, has given rise to basically a new field within AI that's called explainability or interpretability. And it's this study of trying to understand why the model makes a certain prediction. Just some examples to conclude, stuff that I am working on together with my amazing PhDs. One is here today. So we are working on designing tools to explain language models' decisions, and we do it with specific application to the task of machine translation, so that a user of machine translation may be guided to understand why machine translation made a certain mistake, or in the case of question answering, when the model produced a certain answer, did it use a specific context that we provided to it, or did it just spit it out what it had in its parameters? Can we ground this answer to a specific document that the model has seen. Another example, we can work on other languages, and particular low-resource languages, or any language that does not enjoy this high resourceness that English can enjoy. And we can evaluate the accuracy of the answers in those languages. And we can also compare the answers to the same question posed in the different languages and see if the answer match. And the spoiler alert, the consistency is very low. We found for a specific type of questions, namely factual knowledge questions, if you ask it in different languages, especially if the languages are not related, you are very likely to get different answers in different languages. Also not very ideal. And finally, another line of work that I really care about is to try to improve language models for these languages, for the lowest resource languages, and to make them robust to languages that have different properties. So not just English and its related European languages, but languages that have a very different ways of forming words, of putting words together, of ordering words to make a sentence. Can we improve the ability of this model to be robust, to learn any language that humans can speak? And that's it. I would like to thank you for your attention, and I would like to say a few words. Let's take these ideas and make some noise. Thanks for being an awesome audience. ChatGPT word.
Well, thank you very much for your very interesting and informative talk. Are there any questions? We'll only do 1 or 2 questions because we're a bit short on time, but...
My question is, could it be helpful that AI text generators send a sign and make totally clear that it was written by AI?
Yeah. So you mean... yes, it's called watermark, I believe. So that's also a topic of research. So it's this idea of leaving a trace in the text that is generated, so that it could be visible or not. Probably not to the raw eye, but there would be another software that inspects the text and recognizes this trace and understand that it was produced with the model. And yes, there have been a few papers that we have seen, and there is a way to do that. For instance, you can blank some words you can reduce the probability of some words in the vocabulary, and then the model can still generate a very good answer, just it will not use some words. So if you know which words were removed, you could understand it with another software. There are 2 problems with this. It's still really recent research, so it's not really guaranteed to work. Second, you can paraphrase the text. So say you have a malintended user, you can probably paraphrase the text and get rid of the watermark. For now, at least, it's not very robust to this type of attacks. And thirdly, the entire model of watermark relies on the willingness of the company to deploy it, right? So we as user cannot do anything. But it is a direction that it might become maybe a legal requirement that the companies deploying this model do that. Yeah, very good question.
So I think this is all the time we have. So if there's any more questions, then we'll move it to the drinks. So I would like to hand you
thank you.
As a thank you for giving this talk.
Thank you very much. Thank you for inviting me.
Yeah, no problem. And then
drinks.
So next month we will have a lecture by Professor Slotboom on de ontwikkeling en toepassing van cryotechnieken. So please feel welcome to join again next month for this lecture, and see you at the bottle.